So our next exam, which is going to be called as final, will actually cover only a half of material that will start with chapters 11 and 12. And of course, we also have some of chapter 3, right? That's the one we've been working on. But from now on, we'll move to this page 693, looks like. And let's see what's going to be happening in there. Actually, this story of chapter 12 is very different compared to the other things that we have been already learning in this class. And this deals with so-called counting principle. And I think the good idea is to look at so-called tree diagram that is nicely shown here on example and figure 11.1. So they say that someone has 2 pairs of jeans and 3 t-shirts. So it turns out that with each pair of jeans, so it looks like there are 2 of them, blue and black, any of these 3 t-shirts the gentleman has could be worn, and you can see that total number of choices that for the outfit that person has will be 6. They're all listed here on the picture that is called as a little tree diagram. And how we get 6? Well, we have 2 choices for jeans and 3 for t-shirts. And whenever they say and, means we need to multiply. I guess that's the key idea of this particular section, that counting principle or multiplication rule says you multiply number of choices for one by number of choices for the other if they're totally independent. What does that mean? Well, if somebody says, you know, if I wear blue jeans, then I'm not going to wear blue t-shirt or something like that. So you put some restrictions. Well, then it's a little bit less obvious. But if you don't really care what t-shirt and what jeans to wear, then you just multiply them and get your total number of selections. And that's called counting principle. So you count the total number of ways to select those things. So it looks like multiplication rule is a main one that they are talking about. And please notice that problems get more and more involved with bigger size of selections. And here, for example, when someone has 30 jeans and 20 t-shirts and also 12 pairs of sneakers, you're definitely not going to make that diagram for all 30 pairs of jeans, because that's going to be a lot of jeans, right, to list. And then 20 t-shirts, that'd be even more. So this diagram will definitely take you probably entire wall in the room to put all of this information on it. And that's the reason why we would rather do the algebraic way to solve problems instead of intuitive tree diagrams, simply because it will take you a while to produce that so-called tree diagram otherwise. So that's why we, besides getting nice intuitive approaches that most people would definitely prefer, well, sometimes we don't have a choice, because if you would try to draw 7,200 possible outfits, well, that might take you probably a few days, right? There are lots of things to draw. And that's the idea. So when problems get more complicated, well, we have to use formulas because we simply don't have a choice. But if problem is having smaller numbers, more straightforward, well, then you could just do this intuitively. So here's very popular type of exercise that most of you, I'm sure, encountered when took multiple choice tests. Remember, when you do this type of a test, they tell you to select either A or B or C or D. Well, sometimes there's also choice E, but looks like for this exercise, you have to select only one of these choices. And they say there are also total of 10 questions that you have to answer in here in this particular exam. So you have 4 selections for question 1. So you could choose, let's say, C or A or B or D. So you have a total of 4 choices for the first question. Then you have same as many for the second question, and same as many for next. So it looks like you have a total of 10 times 4, which is 4 raised to the power of 10, or more than 1,000,000 possibilities. Of course, if you're doing it by pure guessing, I know that some people usually say, oh, I'm going to eliminate those choices that make no sense, and then it'd be much easier for me to guess. Yes, so when you are a little bit familiar with the material, you definitely can do that. But in this particular question, they just want to know how many of different possibilities will be to answer this 10-question multiple choice test, and looks like it's actually over than 1,000,000. That's a lot of choices. So it's not that easy to guess. In fact, it's very difficult to guess, right? So anyways, that's why if someone says, you know, Alex, I like to have multiple choice tests because I'm a very good guesser. Well, maybe you're a lucky guesser, but out of 1,000,000 selections, it's not that easy to select the correct one, right? So that's an interesting thing to realize. Example 6 also talks about selections and deals with various possible phone numbers, but now we have a little bit of restrictions. We know that phone number consists of 3-digit area code and then 7 digits phone number. And turns out that there is a restriction for the area code. They say they cannot begin with 0 and 1. So it looks like we have only 8 selections then for the area code. They actually put it here. So what does 8 mean? Do I put 8? No, not really. You actually can choose either 2 or 3 or 4, even 8, all the way through 9. So it turns out there are a total of 10 digits. You can count them: 1, 2, 3, 4, 5, all the way to 9. There are 9 digits and a 0 on the top, so a total of them is 10. So if you excluded 2 choices, 0 and 1, then what's left will be just 8 selections. And that's what they put here. It looks like they also have a restriction for the actual phone number, and that seemed to be also no 0 and 1 to start the phone number. So all phone numbers cannot start with a 0 or with a 1. So they can only start with 2 or with 3 or etc. until 9. So it looks like if you have those 2 restrictions and no other restrictions at all, then you have 8 for the first and 8 for the digit number 4 here, and then 10 choices could be utilized for the rest. And you see how many different phone numbers they can produce. That's a lot of phone numbers, right? Over than 6 billion. And again, we use this so-called multiplication rule. In other words, we just take numbers and we multiply. So let's practice a few exercises here. I hope this section will make you feel pretty good compared to the previous chapter. So we started to get into logic deeper and deeper, and the problem started to get pretty long. I'm sure that here in the section 11.1, you're gonna enjoy this much better, because problems here much shorter, I believe. So they say student is planning a two-part trip. So there is a first leg and there is a second leg of the trip, looks like. And they say that first leg is from San Francisco to New York. And then the second leg, travel options include airplane, second leg from New York to Paris. So they say for the first leg, the choices are either airplane or train or bus. So technically you can go from San Francisco to New York. Probably fastest is airplane, but there is also train option. Did you know that? Or if you really have plenty of time, then you can also use a bus. So I can list this here: airplane, train, or a bus, just like that. So that's for the first option. Now for the second option, you could either fly or you could use the ship. So for the second choice, it's either again airplane, which most people will probably use, right? But some people can take a cruise ship, for example, if they feel like it, and cross Atlantic by cruise. Interesting, right? So anyways, what I just did, I produced a so-called tree diagram. So it's just like branches of the tree that analogous to what we have seen in the first example in that section. And what I did, I just tried to list all of the possibilities. If I go along the branch of the tree, let's say very first choice will be just take airplane, and for the first leg and for the second. Or instead of going on the airplane across the Atlantic, you can take a ship. And analogously, I can utilize train for the first choice and then either airplane or a ship. Or I could start with a bus and then go airplane or a ship. So it looks like we have this 6, right? You can see I listed total of 6 possibilities here. And one can say, Alex, if somebody told you that there are 2 choices, actually 3 choices for the first leg, and means times 2 choices for the second leg, then you could just multiply 3 by 2 and get the 6. That's what they're actually asking about, was the total number of various possibilities, instead of listing all of these choices, so you get your answer right away. Yeah, I think that's definitely a faster way, but again, if you want to see why it's 6, then you can actually list all of those using so-called tree diagram. Let's do another one. Say exercise number 9 has a little table. Let's see how we can utilize information from those tables. So this exercise talks about various choices for the restaurant menu, and question is how many different orders are possible? How many ways, or what would be the total number of orders that one can go with if they want to get a main course, vegetables, beverages, and desserts? So for exercise number 9, I have a main course with 4 choices. Do you see this? 4 choices, either ham or chicken or fish or beef. So you have 4 choices in here. You also have 3 selections of vegetable. And you have 4 selections for the beverages. And you also have 3 choices for desserts. So looks like you need to multiply these because they say they're totally independent. So you don't say, oh, I just got a coffee, so I'm not gonna go with ice cream, for example, or with green beans because I have that coffee, so I don't eat it with. So if so, then there'll be some restrictions. But if they didn't tell you any restrictions possible, then you just multiply all of those. And if you multiply 12 by 12, you get something like 144 for the answer. So it looks like there are a total of 144 various menu selections that person has. Well, no wonder some people stay in the restaurant for a while studying the menu because there's just so many possibilities and it's hard to decide, right? So multiplicative rule is all about multiplying, which is not surprising. So let's try one more here. Let's say exercise number 18. That talks about 7-digit telephone numbers somewhere in California that have 669 as the first 3 digits. So if first 3 digits already been taken, then how many choices will remain for the last 4? And I would say there are 10 possibilities for the first of them. Remember why? Because we have total of 10 digits that you can put here on that position. You could either put 0 or you put 1 or 2 or 3. So you have 10 choices. Same exact 10 you have for the next position and for the next, and finally for the last. So when you do this multiplication, because it means and or times, right? We're going to get 10 raised to the power of 4. Well, and it's not very hard to write it down. It'd be 1 with 4 zeros. So 10,000 different telephone numbers. So we're just multiplying and that's about it. So I think this first section of chapter is pretty nice because you don't really do much but multiply. So let me try one more and then maybe you can try one. How about if I do problem number 20? That talks about different 4-letter radio station. So we are thinking again about 4 choices, right, for the letter. If the first letter is either W or K. So it looks like for the first position, I have only 2 selections. I have to either put W or K. And then question is, how many letters are there in the alphabet? Well, one can say it depends on what alphabet, right? Well, we assume it's an English alphabet. So 26 letters in the alphabet from A through Z. Did you know that? And for the next choice, you have 26 possibilities. And for the last one, also 26 possibilities. So I multiply these numbers. And of course, I will rather use a calculator for this particular one. So let me see, do I have a scientific calculator? We can just start typing scientific calculator. And there is a choice number 1 called Desmos. That's the one I always use. I don't use this one that Google provides. It's not very convenient calculator. But Desmos is the best because it shows everything that you're entering. So you can see if you mis-entered something, like if here you put 26, then you can see it. And then times again 26. And there we have it. Over than 35,000. It's actually 35,152 various possibilities for name of radio station. And looks like we're doing exact same thing in pretty much every exercise here. So we're just multiplying those numbers. So how about if you try one to multiply? I'm sure it'd be a fun thing to do. Like exercise number 8 as a little quiz for today. So what it says is you need to find the total number of one topping pizza that could be selected. So it looks like you have 3 choices for the size, you have 4 choices for the crust, and finally 6 choices for one topping. So you just order in one topping. When you say, Alex, I always order 5 toppings. Well, here's the question, only one topping pizza, only one. So as usual, please put your answer in the Zoom chat. And I think that'd be